Okay, so if I'm talking about the product of E and 4, you got to know what a product is. That's the answer to a multiplication problem, right?
Yeah.
Okay, so that's the first thing. But how would we write the product of E and 4? Yes? 4E. Okay, now would this answer change if instead of it saying the product of E and 4, it said the product of 4 and E?
No.
It would still be this, right? So it doesn't, the order doesn't matter when you're talking about multiplication. It only matters when you actually write what it is. And we know the number, the coefficient, has to be, the order does not matter when, it doesn't matter, multiplication is commutative. But when you write it, you always write a number times a variable as the coefficient, then the variable. Whereas if it's the quotient, I know that's sloppy, but that's the answer to a division problem. If it says the quotient of E and 4, then I'm looking for E divided by 4, right?
Yep.
In that order. If it says the quotient of 4 and E, then guess what? I want it in that order. 4 divided by E. Everybody got that and understand that?
Yeah.
Okay, the other thing I quickly wanted to recap was number 11 from your formative. So flip to page 2 in your formative. It's a pentagon on there, I think it is anyway. And I'll show you with a triangle, but it doesn't matter. It's any shape, okay? First of all, we've got to know what perimeter is. And perimeter is the distance around anything, okay? So to find perimeter, you add up all the sides. So I see that, let's say it was like this. What would my perimeter be of that triangle?
13.
13. 4 plus, it would be 4 plus 4 plus 5, which equals 13. Right?
Right.
Okay. So that's that. So I just wanted you to see that. Okay, instead of doing that right now, just listen. Okay, don't worry about it. Okay. Rather than doing that, well, obviously in this chapter, it's all about expressions. So you might be given something like this. You might be given 2 parentheses x plus 2. You might be given the opposite of negative x plus, that's supposed to be a negative right there, minus 1, and then you might just be given 2x, something like that. Well, nothing changes here. It's all the sides added together, right guys? So you'll write this side from this side we know is 2 parentheses x plus 2 plus, and then we're going to add this side now. Or you could just distribute, actually we probably should just distribute it at this step. We're going to distribute this and make it 2x plus 4. We're going to make this positive x plus 1, right? Isn't that what that equals? Hello?
Yeah.
So we'll actually write that rather than writing that all out. Okay, so I get 2x plus 4 plus x plus 1 plus 2x. So just to make sure you guys are all aware, this right here in yellow, that's representing that length from there to there, right? X plus 1, that's representing that length from there to there. And this length right here is representing that length from there. And that's how we find perimeter. Now let's look for like terms. I see 2x, I see 1x, and I see 2x. How many total x's do I have? 5x, right?
Yep.
And then I have the constant 4, the constant 1. That's going to give me plus 5. Okay? And then if I were asking you to factor that expression, then you would say, okay, what factor does 5x and 5 have in common? 5. And then you'd say, okay, what would I multiply 5 by that would get me back to 5x? X or 1x, but we just write it as x. What would I multiply 5 by to get me back to 5? 1. There you go. You don't have to do this, but if it asks for it, I just want you to know that's what it's asking for. It's asking you to factor that. Does that help everybody? The other thing that I want you all to see, that a very common mistake, is something like this. If I gave you 2x plus 1 over 2 plus x minus 1 over 4, and then say minus x over 5, something like that. And I told you that x equals 5. I want you guys to all see this so that you're all given a fair shot to see exactly what my expectations are. Because I will count it off if you don't show the steps. You guys understanding me? I will not accept it if you get the answer. It's not just about the answer. Okay? Same goes for if you miss it, but you have most of the work and you made one small math error, I'll probably give you a half point with it. So it works both ways, right? It's more about the process than it is about the answer. What's the first thing that should happen on this algebraic expression right here? Yes? I want to put parentheses around any expression that's in the numerator or denominator of a fraction. Okay? Now, what's my second step always? Yep. Turn that algebraic expression into a numeric expression. So that's going to be 2 times 5, because I said x equals 5, plus 1 divided by 2. I'm going to make this plus 2 just for the sake of it being a whole number. Make it plus 2, plus 5 plus 1. I'm going to make this a 6 just for the sake of it being a whole number. Okay, just so that we don't have to worry about it too much. And then 5 over 5. Okay? Now, have I even done really any math yet? No, I have not. So now I'm going to follow PEMDAS. Right? Now, everybody please watch, because you're going to be very upset if you don't have these steps. How many steps do we do at a time? 1. So I'm going to start on these parentheses. Am I going to multiply or add first? That's going to give me 10 plus 2. Leave the parentheses on. Divided by 2. Plus 5 plus 1 over 6 minus 5 over 5. And then I would do 10 plus 2. Then I would do 10 plus 2 and I'd get 12 over 2 plus parentheses 5 plus 1. Do you guys see what my expectations are? One step in rewriting. And I won't continue the problem, but that's what I want. Then you would do this step next. Then you would start dividing left to right, and so on. Okay? Learning target number, what was it? Learning target 3 video is if you still need work on those. I do want to give you this one, though. A lot of people are missing this. This is 1. That's an algebraic expression, right? Hello?
Yeah.
What I tell you the first step to every algebraic expression is when you're evaluating them.
Find the.
No, turn that algebraic expression into a numeric expression. And then you would go, okay, well that's 3 times y, so it's going to be 3 times 2 to the 3rd. So what would you do first? The exponents, right? That's going to be 8, and then 3 times 8 equals 24. But here's the problem, guys. I got a lot of students that do this. This over here will be the wrong. This is wrong over here. This is good. This is what I see students doing on this one. They put a 2 in there and they say, okay, 3 times 2 is 6. 6 to the 3rd is 36 times 3 is 108, I think.
Yeah.
Okay? I see a lot of people doing that. Do you see their mistake? They broke the rule of PEMDAS. They multiplied here before they did exponents. I'm just going to warn you right now, there's one similar to this on the test tomorrow. Okay? So, I would definitely take a look at that. Just make sure you're doing what I told you. Take the algebraic, turn it into a numeric, then simplify one step at a time. Okay, this one. Okay, I want you guys to all see this. This is the one that was similar to the one on the formative. I just want you, once again, all to see what the expectations, because there will be one like this on the summative. I promise. Okay? You're going to select all that apply. But you know what? If you just go through here and circle the right answers, I'm going to count them wrong. I just want you to know that right now. That will not be accepted. Okay? You must prove why they are correct or incorrect. Okay? So the first thing I'm going to do is I'm going to expand this. 9 times 3 is 27. 9 times g is 9g. So just from that, can I go ahead and eliminate a and c? Yeah, I mean, they're different variables, right? So that we don't have to worry about that. Okay, then I get to letter b right here, right? Because that's the exact same, correct?
Yeah.
Now, what property allows d to be correct also? We should probably write that, because that's you proving it. I want you to be able to prove that that is, because the commutative property of addition says the order in which you add your 2 terms or 3 terms can be flip-flopped. Okay? Now we get to E and F. This is where the real work is required, so please watch. You're not allowed to just go ahead and say, oh, it's this one, I just did it in my head. That doesn't work. You must actually expand this and then simplify it like this. So 10 times g would be 10g. 10 times 3 would be 30. Okay, now we got to distribute a negative through, which we know means take the opposite of whatever's inside the parentheses. We have a positive g, so that's going to become what? Negative g.
Negative
I have a
g.
negative 27, so that's going to become a what?
Positive 27.
Okay, so I look here and I say, okay, I got 10 g's, but here, don't I have a negative 1g? Right?
Yeah.
So what's that going to result in? 9g, exactly. Now I'll go to my constants. I have a constant 37 and a constant 20, I'm sorry, a constant 30 and a constant 27. When I put those together, what do I get? 57. Now is that going to be equal to that? No. Do you see how I proved, though, that letter E would not be the same? Does everybody get that?
Yep.
Okay, now I got to do the same thing for F now. So we're going to first of all expand it. So that's going to be 10g plus 30. Now I'm going to expand the negative through. That's going to be negative g minus 3. Does everybody see that? Okay, well then I have 10 g's and I have negative 1g. That means I have what? 9g. I have the constant 30, but here I'm subtracting 3. So how many do I have? So I have positive 27. Now, is that going to be the same as that?
Yeah.
Did you see how I proved it? You have to prove all multiple choice answers. You just can't circle it. Understood?